All right. We're going to talk today about confined space awareness, and then after this presentation, Hempel's got a presentation on grain awareness. All right, for the confined space awareness, we're going to cover the objectives. We're going to define what a confined space is. We're going to define whether it's a permit required or non-permit required confined space. We're going to talk about some hazards associated with them. We're going to talk about some OSHA requirements, go over some safety, some factors considered in rescue, and then kind of a review of our SOGs and equipment carried by the Salina Fire Department. Everybody still on board?
We're good.
Okay. What is a confined space? To be for a facility to or have a spot that's considered a confined space, it has to meet all three of these three factors as described by OSHA. It has to be a space large enough and configured that an employee can enter and perform work. It has to have limited or restricted means of entry or egress, exit, and is not designed for continuous employee occupation. So a lot of machinery, like at Tony's, grain elevators, Phillips, places all over have these. They got to get inside, tanks to clean, water towers. All that's considered confined space. To be a permit required confined space, that means that they have to follow through some of the, all of them have to follow the OSHA regulations, but there's a document they have to fill out that's called the permit, and for that to happen, it just has to meet one of these following conditions. Needs to contain or has the potential to contain a hazardous atmosphere. Has to contain material that has potential for engulfment or entrapment, like at a grain elevator. Has the internal configuration such that an entrant could be trapped or asphyxiated by inward converging walls or sloping floors. Again, an elevator, trash trucks, machinery, and contains any of the recognized safety or health hazards. Everybody still on board?
Yep.
Keep going. It's not a permit required space, and it's a non-permit required space. It doesn't meet one of those criteria back there. OSHA defines a non-permit space. The spaces do not contain, or with respect to hazardous atmospheres, have potential to contain any hazard capable of causing death or serious harm. So when we go out somewhere, if we get a call somewhere, don't get fooled into, don't get tunnel vision to thinking there's no hazards. If you get there and they say, Johnny's down there, and you start asking documentation, and they say, well, we don't have any, it's a non-permit confined space. Well, something got us called there, something changed, and now it is a permit for required confined space as far as we're concerned. So we've got to make sure we don't jump in there and create more victims, more problems. Hazards with confined space, there's two main hazards: hazardous atmosphere, mechanical and physical hazards. Hazardous atmospheres. Years ago, coal miners used to use canaries to find out when there was coal gas in the mines. Sometimes they would use candles. They would lower candles down into a mine or pit to see if the oxygen was sufficient enough to keep the flame burning or not. Well, luckily today we have monitors out there. Station 2, what are we looking for when we use one of our monitors? What are the 4 things we're looking for on our monitors?
The O2 level, our LEL, and then if we're just using our poor gas, it's going to be then your H2S and your CO level.
Perfect. Somebody want to answer what type or what monitors do we carry here at the fire department? What are the different types of monitors we're carrying?
PID, 4 gas, array, area array, 4 gas.
All right. So we're dealing with hazardous atmospheres. What's going to be our PPE, required PPE?
FTBA.
All right. OSHA defines a hazardous atmosphere as any atmosphere that may expose employees to the risk of death, incapacitation, impairment, or the ability to self-rescue. So, on to physical or mechanical and physical hazards. Actually, let's stick on how are we going to handle mechanical and physical hazards at the fire department? Somebody here from Station 4. What are we going to do?
Lockout, tag out.
Lockout, tag out. Perfect. Where do we keep the lockout, tag out on our department?
Toolbox.
1, rescue 4. Yesterday there was a suggestion that we buy 2 more of them and put one on 420 and one on 441. So we're going to look into that. All right. How do we monitor the atmosphere? What's our procedure at the Salina Fire Department for monitoring the atmosphere? Start upwind. Okay, SCBA until you know something different. All right. Somebody from Station 2 want to talk to us about how we're going to monitor the atmosphere, how we're going to approach a scene or an incident?
Well, we'll take Rescue 4's long tubing connected to the monitor, and then we'll measure a few feet at a time until we get down to wherever we're going to work, looking for any change in the atmosphere conditions.
Okay. What's the time lapse on those monitors? How much time do we need to let it stay in a certain position? Do you remember?
All depends on how long your tubing is, and we've got that. I think Rescue 4 has all that numbers, but basically, if I remember right, it's like 12 seconds a foot.
Okay. All right. So, when we're considering monitors, what's going to be our acceptable range of O2? Station 3, got any ideas?
I think our minimum is 19.5, around there, up to 23.
19.5 to 23 point, or 23.5. Lower explosive limit, we're looking at 10% of the lower explosive limit, and we're looking for how many parts of hydrogen cyanide, or what's the other? 10 parts per million or something like that, I believe. Is that right, Greg?
Yes, that's correct.
Okay. All right. If everybody's still on board, we're going to move on. Some of them are muted, and they'll unmute as they talk. With respect to types of mechanical and physical hazards that we can encounter, we're going to encounter electrical hazards, whether it be the source electric or tools that they were using in the hole, manufacturers, elevators, whatever, you're going to find agitators, paddles, augers. You're going to find machinery that you can get entangled in, or the employees are entangled in. That's why they've got a problem in that confined space. You're not every time going to find difficult to access areas. You're going to have problems with the physical state of the materials that you're dealing with. When Larry talks about the grain class, about how it wants to keep coming back in on you, and in the engulfment. Anybody have any questions up to this point? Hearing none, we're going to keep moving. Things to be aware of when dealing with a manufacturer manufacturer processes, Tony's, Phillips, any of those, the grain elevators. You're going to have fuel lines, you're going to have product lines, you're going to have air lines, agitators, you're going to have heating and cooling equipment, and drive shafts on the machinery. One thing we need to be aware of when we go to one of these incidents, we need to get one of their people to be right there in your hip pocket. They're the experts on this stuff, not us. You know, they know how these machines work. They know what's going to happen if we flip this switch or that switch or turn this, turn that. So we need to make sure we have one of them with us to be our expert and to assist us in what's going on. We don't want to make this situation any worse than it is. And we need to be very cognizant and keep in our minds that we need to be very careful around these things because, like I said, we're not the people that built it and we don't know everything about them. So we don't want to become a secondary victim. Lockout, tag out. We need to make sure we get those kits out every so often and see what's in there, see how they work. One thing I thought was interesting yesterday is Stansbury took one of those lockout, tag out devices and you can actually lock the cell phone in there, and Rob did not like that yesterday because he couldn't access his phone. So we have lockout, tag out that we can lock out, tag out electric. We can lock out hydraulics, pneumatics, chemical stuff, thermal, and gravity. As that regards to those type of hazards and why we're going to lock those out, electricity, we can be endangered through burns, through electrocution, high temperature arcs, fire ignition, arcs again, and with respect to hydraulics, we got to keep in mind about being crushed, getting cut, pinched, other injuries that can cause injury or death. Pneumatics, there again we can be crushed, trapped, or asphyxiated. Chemicals, you know, they're going to have the toxicity, corrosivity, flammability, reactivity, engulfment, and potential to be drowned. Thermal, you're going to have potential for burns, hypothermia, displacement of oxygen. And gravity, you're going to be, your main concern is engulfment, crushing, or being struck by any tools or any of the equipment in there, or displacement of oxygen to cause death. That's the reason we want to lock that stuff out and tag that stuff out. That's why when we want to get to one of these facilities, if we go to a facility like a grain elevator, typically they will have everything locked out and tagged out. We just need to make sure that that's been done. And we need to put our lock on that same deal and verify that that was done. We just don't take Joe Bob's word for it.
Sure, Bob. You're going to get me one question.
All right. Anybody got any questions up to this point about lockout, tag out?
Who's the person that decides when we're done with it? They can remove all those tags.
Okay. Question: who decides when we're done with it, who can remove all those tags? That would be the command. Whoever's in command of the operation, when he deems that it's over, it's done, and we turn that facility back over to them, they can remove their stuff. That's when we'll take our stuff off of there, and then they can
Turn it back over to
the facility, and it's up to them at that point. All right, here are no questions. We're going to move on to some OSHA requirements. OSHA 1910-146 contains all the confined space requirements. The four main things that are required with respect to confined space are, when we talked earlier, if it meets those three criteria to be a confined space and meets one of those criteria to be permit confined space, it has to have an entry permit. OSHA defines that as a written document that must be completed prior to entry into the confined space that defines the hazards of the space, the precautions to be taken, the type of work that will be performed, and the roles of the employees involved in the entry, and any other specific details pertinent to that confined space. Number two requirement. for the OSHA standards. That confined space has to have what they call an attendant, a person trained and assigned to remain outside the confined space to monitor the conditions in the space and outside the space, and is the communication with people in the space. That person cannot leave. He is not a gopher. He is not. He's not going to look for information. His job is to sit there at that hole and not leave. He has to monitor the air outside the space, the air inside the space, so he's going to need at least minimum 2 monitors there. And he's also the one that communicates with the people in the hole. We understand that we cannot leave that space. When we get there, we're going to have our own attendant there, and you can't get equipment off the truck just because somebody says they need it. Next requirement is required by OSHA, what they call the authorized entrant. That's the person that's trained, assigned, and equipped to enter and work within the confined space. Go to one of these confined space for a rescue, that person is going to be us, and hopefully we're trained, we're equipped, and we're assigned to enter the confined space, and that we're known as the rescue entrant. We're going to treat it basically the same as what we do at hazmat. You're going to go through the whole medical deal, geared up, double checked, triple checked. You know, you're going to be told, or should be told, what the hazards are that you can encounter, what things to look for, and what you need to get done while you're in there. Fourth requirement is required by OSHA is a confined space supervisor. That's it. That's going to be our expert. That's going to be the person assigned the responsibility for ensuring that the requirements of the confined space program have been met prior to, during, and after entry of the person into the confined space. So, also, another requirement of that confined space supervisor is he's the one that verifies the rescue services will be available and that there's means to summons them. Can you guess who the rescue services are going to be for their confined space when they're doing work in one of those holes? That's going to be us. And they make the assumption that when they dial 911, we're going to come and we're not going to be busy with anything else. So. I need lunch. When we go to one of these confined space incidents, things that we're going to need to get a hold of, we're going to need information. We're going to need to get a hold of that permit, or if there's not a permit, if it was a non-permit confined space, when we got there, we're going to have to create a permit and to get this thing going. We're going to need to verify on that permit that it's the right date, the right time, make sure that this is the permit that goes to what's going on in that hole right now today. Make sure they didn't try to just slide something in. Have to make sure that, you know, what's going on in that space. We need to identify what those people were doing down there, what their tasks were, and what problems that they were encountering, and what problems they got into. We're going to need that entry supervisor because he's our expert. He's going to know the people to contact to let us know what's going on in that hole, and anything that we do, what's going to be the adverse reactions, or if it's going to help or hurt the situation. We're going to need to know who the attendant is and how many entries were in there. We're going to need to check the atmosphere. We're going to have to double check that atmosphere. You know, just because their monitors say it was good, evidently something's wrong. Let's double check and make sure that everything is still good. And we need to do that before and after. That we talked about yesterday was when you get to one of these scenes and the guy's standing there and he's talking to you and everyone's around the hole and they're talking to you, you can be fairly sure that everything on the outside is good, where you can go up to that confined space. But you still need to document and to check with your own monitors to verify that that's the case. Need to know what kind of ventilation's going on in the hole, or the situation, what's been effective, what's not effective, what's available to us. And then we need to know methods of controlling the hazards, what's in place, lockout, tagout, product line shutdowns, stuff like that. Safety considerations when it pertains to us. Things we need to consider, just like we consider in hazmat, you know, whether it's a hot environment, cold environment, or for Tony's working in their facility, it's going to be really hot, or it could be potential to be really cold, depending on where you're at in their building. And to determine the PPE and the respiratory protection we're going to need, we're going to need to set up medical monitoring, just like we do in hazmat. We need some baseline vitals and everything. We need to pick an appropriate PPE for the environment that we're going into. At a minimum, we're going to have the harness for your retrieval and just your regular duty uniform minus shorts. No shorts are allowed in confined space. Preferably a long sleeve shirt, a helmet with a headlamp, hearing protection. Keep in mind that when you go to one of these places that's having a problem, it's going to be loud. And so we're going to need those earplugs that you stuffed in your pocket somewhere. Just make sure you still got them in your coat pocket. And then we're going to need retrieval equipment. What type of retrieval equipment? How are we going to get that person out of, how are we going to get ourselves out of this situation if something happens? And how are we going to get the victim out? Rescue procedures, kind of the down and dirty of what's going to happen when we get to one of these scenes. We need to establish command. Identify the type of rescue, the problem that's happening. Did the guy just fall his leg down the hole, we just need to get him out? Or do you have an emergency, like a heart attack or something? Or, you know, they just lose contact with him, and we need to go rescue him, or at least make contact with him to see what's going on.
Yeah, goodbye.
Got to perform a hazard and risk analysis of the situation. You know, is this going to be a victim, or is this going to be a body recovery? Because that's going to slow things down tremendously if it's going to be potential for body recovery. Identify our risk objectives. Identify our resources we need. This isn't going to be just a single company response. If you go to one of these incidents, it's most likely going to be a call back or notifying the hazmat team, the technical rescue team, or at least calling back to people to help with the situation. You're going to need to develop an action plan. You're going to need to implement that action plan. You need to evaluate that action plan as the incident unfolds.
An interlude.
That was the calendar appointment reminder that today's Funky's birthday, so if you see Funky, tell him happy birthday. And at the end, we're going to terminate that incident. That's when we turn that facility back over to the owner-operators. Main thing to remember, and one of the books I was reading is to good with anything that we do here. The kind of a quote is, the sense of urgency many of us feel during the rescue work blinds us to the true nature of the hazards and can allow us to become victims. Don't become that victim. That's why these OSHA requirements are in place. There's too many people where Joe blows down and I'm going to go help Joe blow. Well, instead of trying to figure out why Joe blows down, they just ran in there, and then we started piling people up. We started piling firemen up in holes, and we don't want to do that. So we just need to stop and think. We need to think about your safety. Your safety is our priority. You know, we didn't cause this problem, so all we're here to do is help and to make this thing better. We don't want to kill one of us in the process of doing it. Proper PPE whenever we go into one of these things. Is it going to be a chemical deal? Is it just going to be a simple go in, splint a guy, and bring him out? you know, or is this going to be a medical emergency where the guy's code blue and CPR and blah, 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 or is this just going to be a body recovery? Prepare yourselves. It's up to you guys, your crews, to review the SOGs. SOGs in the book is S900. You need to review the confined space forms on T drive. I'm going to work to try to get that form changed a little bit, turned into more of a checklist type form that we can use in any or many type of events, confined space, hazmat kind of a deal. You need to review your equipment that we carry, ropes, tripods, inline Scott, spec pack, fans, ventilation equipment, and you need to brainstorm your areas, pre-plan your districts. When you go in there and we're doing our walk-arounds and you see that sign that says danger confined space, maybe do a little bit of look in there, kind of see what's going on, maybe in your mind kind of plan, if we had somebody trapped in here, how am I going to get them out? Okay. And the main thing is we need to get out and we need to train. So I ask you, are you ready? That's a question only you can answer. So with that said, that ends my deal. Anybody got any questions for me?
Station 3 is ready.
Yeah. Should go left. Class is over.
No, class isn't over. But what we will do is we'll